Hello guys, welcome to this episode. In this particular episode, we're going to go over Leetcode problem number 2, the solution for that. Actually, I had made the video earlier, but I realized that the orientation of the video, like it was horizontal, and it was a disappointment because I thought it was an actual full widescreen, but it turns out it wasn't, so I'm remaking this video. Anyways, so I apologize if I've already written some of the code here, but I'm going to rewrite some of the stuff, but you don't have to worry about that. But I apologize for any confusion or technical difficulties, okay? Alright, so this is problem number 2, and basically this problem just says that you're given two non-empty linked lists representing non-negative integers. So basically, this is, non-empty in the sense that, you don't have to worry about the linked list being empty, right? Like no elements. And each of the digits is non-negative, so you don't have to worry about them being like negative digits, okay? The digits are stored in reverse order, and each of the nodes have single digit, right? And so add the two numbers and return it as a linked list, okay? So that's pretty much it. I mean, the linked list, both the linked lists have are in the forms of digits, right? So, where each node has a certain digit, and we have to add them and we have to return them. The important part here is that they're stored in reverse order, right? And this actually makes it convenient for us in a way if it's actually stored in reverse order. We'll see how in a second, but it's actually much easier because we don't have to worry about we can just propagate, we can add and propagate the carryover as we go along. We don't have to worry about any other additional stuff. And the assumption is that you may assume that two numbers don't have any leading zero except for 0 itself. So if you have the number like 23, you don't have to worry about there being 0, 2, 3. Like you can just assume there's the number 23, right? So let's look at the example here, right? So in the example here, the first list contains 3 elements, 2, 4, and 3. Second list contains 5, 6, and 4. We are given a function header to complete, which takes in the list of the, we're passed in the list of the head of the first list and the head of the second list. So both of these are linked lists, and we're passed in the head of each of those lists. Okay, and we have to add them, right? And keep in mind this is in reverse order, right? So the actual digits for this would be 342, right? And 465, 465. We would add them up, 807, right? And so this would be our output, right? 708, because we're storing it in reverse order, okay? So, and like I said earlier, it's somewhat easier because, I just start from the last and add and just start propagating the carryover. That's the basic idea here, right? All right, so let's think about how we can approach this problem really. So firstly, the idea is that we want to sort of return a new list, right? We want to append stuff to the list and return a new list, which represents the sum, the total sum of adding the two numbers, right? So the idea here is that we create a temporary dummy node, right? Which has initially 0, right? Which points to nothing. And the idea is that we're going to start appending from this point onwards. And we're going to finally return our list that we just constructed, right? So that's the idea. So I'll call this new list, basically, which points to the head of that new list that we're constructing. And I also need one other pointer that goes through and sets the pointer as I'm constructing the list. So as I am building the sum, I need some other pointer which advances forward. So temporally, it also points to the head initially, but as I'm moving along, it updates the temp, right? The temp moves forward. So this is the result. Linked list that I'm constructing, right? I'm just going to start appending stuff to it. Okay, so let's try to think about how we can do this, right? So add 2, right? Okay, so and this takes in L1 and L2. We're given those two things. Okay, so let's take an example here, right? So the idea is pretty straightforward, right? So we start at the first node, right? And we also have the pointer to the second, the head of the second one, and we can just add the two values together, right? And if there is a carryover, we just propagate that along using some sort of variable, and we add that along, right? So it seems pretty straightforward. So let's think about so let's first declare the variables that we're gonna require here, right? So obviously we require carry variable here, which represents the carryover that we're gonna carry it over in the subsequent iterations, right? We also need some sort of we just construct a list here, right? So let me just declare that, right? New list equals node 0, and temp also points to the new list. Okay, that looks good. The setup looks good here. One other thing is that as we're adding up each digits, we can also potentially have a variable called total sum that represents the sum as we're going along and iterating through our given linked list. Okay. All right, that sounds great. So let's actually think about how we'll iterate. Okay, so let's think about how we're actually gonna iterate, right? So going back to our example here, right? We start at the first one, and while it's not null, we just iterate. So this is just standard procedure for iterating through linked list, right? So while L1 and L2, right? So here we have to think about whether this is and or, right? And a good way to think about this is that do we want to process, like do we want to do some sort of operation when both the list ends, or when either of them still has digits, right? So here in this case, even if you put an and, it's fine, but it gets a little tricky because say list 1 is greater than list 2, the length of list 1 is greater than list 2. So say list 1 had 4 digits and list 2 had 2 digits. In that case, if we put an and here, right, this would cause problems, right? Not exactly problems, but it would make it more complicated, because what would happen is that when either of those lists terminate, this entire loop would break, and we would probably need some special code to handle the case where we got to figure out which list ended first, and based on that we got to append the remaining part of the list, and that will get a little bit more complicated. There's actually an easier way, in a sense that if we actually rethink this problem, maybe if we put an or instead of and, in a sense that we want the loop to still be running when either of those lists still have content in them, right? So say this first list is 4, has 4 digits. The second list has 2 digits. Then even if the second list ends, we still want to somehow process and add the sum of the first list as we are traversing through the 4 digits, right? So that's the idea. So instead of and here, if I put an or, that makes it a lot easier. Now let's think about how, right? So if L1, so if we're dealing with the L1 case, right, all we have to do is add it to our total sum, right? Total sum plus equals L1 dot data, right? And we move the L1's pointer forward, right? So here, this is the important part. We have to move it forward because say we're at 2, 4, 3, we add 2, right, to our total sum, and we move the pointer forward. So now L1 points here to 4. Right? We do the same thing with L2, right? So now sum has already captured the result value of L1, right? So we do the same thing for L2 also here. So we say if L2 total sum plus equals L2 dot data, and we move the L2's pointer forward, right? Great. All right. So this seems pretty straightforward so far. We have just added our the contents that is present in the 2 lists, okay, and we have stored it in a temporary variable. So the things that we're still missing though is the carryover and actually appending the value to our list, right? So let's take care of that. So let's also say since we also want to add the carryover, right? We can say something like total sum plus equals carry, right? Okay, so now we counted for the carryover, right? Now we can start appending into our resultant list, right? So now we actually have to say something like, temp dot next equals equals node. So now we're actually constructing the nodes and appending it, right, to our linked list. So this will be something like total sum, right, mod 10, right? So like for instance, so before that, the idea is that like since I have a my own list here, we want to append the stuff to the list as we're going along, right? So say we have some example like, I don't know, like 5 and 4, right? So in this example, or maybe in this carryover, that's a better example. So 5 and 8, right? So we add these two contents. So first L1, we add L1's node item, which is 5, to total sum. So total sum is now 5. We add L2's sum, which is now 5 plus 8, which is 13. So we have 13. So we want to have 3 in the we want to create a node which has the value 3. And we want to do a carryover of 1, right? So that's why if I do 13 mod 10, I get 3, right? So that's going to be my node here, okay? And I'll update the carry. I say carry equals total sum divided by 10, right? So that will, that will essentially do the carryover. So 13 divided by 10 is equal to 1, right? So even if it's like, and the reason why this is 10 10 is that even if you have something like 9 and 9, right, since it's a single digit, at most each node can have value max of 9. So if you do 9 plus 9 is 18, carry over 1, right? So this should work, right? This logic should work, okay? Then one thing we also have forgotten to do here is that we append it, and we have to also move the pointer in our result results linked list, right? So we have to say temp equals temp.next, or else it's just going to keep on updating that one particular node, right, which is here. It's just going to say, okay, I'm going to add a new node here, probably in this example here, it's just going to add 3, and it's going to keep on updating that, right? So we don't want that. We want to advance it, and we want to start constructing our node and adding stuff to it, right? Okay, so is this the right logic? Yes, almost. This seems to work, but let's take an interesting example here, right? So let's take an example, something like this, right? We have 3, 4, 8, okay, and 6, okay? Okay, this almost seems to work, except that we're missing something here, very important. So if you take this example right here, so first we add 7 to it, right? 7, we construct a node with 7, right? And then we construct a node, 8 plus 6 is 14. We construct a node that, and the loop actually terminates after this point. It doesn't actually carry over the 1. The reason being that while either of those lists still have content, you're iterating over them, right? L1 or L2. But the thing is that when you carry over, you might want to create a new node sometimes, right? So this is a bit tricky, right? So we still want a loop to run over if there's a carryover, essentially, right? So that's why we have to tweak our condition here to also include or carry, right? So if we do that, then what's going to happen is that, okay, these two lists terminated, but since there's a carryover of 1, it's going to create the new list with 1, and we're going to have our correct resultant extra node added at the end for our results list. So that's the general idea of it, and yeah, that's pretty much it. And we have to make sure in the very end, after we're done with everything, we return the our new new list.next, right? .next. So remember that new list is actually the pointer pointing to the head of the dummy node, and whatever comes after is our resultant sum, right? So in our case, it would look something like this, like just as an example, right? So here, if you take this example here, it would look something like this: 7, 4, 1, right? So temp actually points to the very end here, but new list is still, we would still need to keep a track to the head of the node so that we can return new list.next, which is where our entire result node starts, right? So that's what we return here, new list.next, okay? Okay, great. So this algorithm seems fine. And let's go ahead and analyze this, right? Okay, so time complexity and space complexity, right? So time complexity, let's think about this, right? Here the loop is running when until like either of those elements still have any numbers in them, right? So it would be something like O of, big O of max of whatever the length of the list is. So in simple terms, what this means is that, say L1 is 4 items in length and L2 is 2 items in length. This loop runs 4 times, right? So essentially, this would be something like mn, right? Where m represents the length of the first list and n represents the length of the second list, right? Okay, great. What about the time complex or space complexity, right? In this case, since we're returning a new list and we're not actually modifying any operations on the list in place, this would be the same complexity as this one, basically the number of nodes, right? So it would still be O max of big of m or n, right? Since we're constructing our new resultant nodes and storing that in memory. But I've observed, like on Leetcode, sometimes they say that, okay, ignore the resultant, whatever the result you're trying to do, ignore the space complexity of the result. I've seen that like on 1 or 2 problems, I think. So, if they give that assumption, then it just uses additional variables that keeps track of the sum, right? So in that case, it would be constant time space complexity. But for this particular example, since they haven't given much information, and since you're constructing your node, the result as you're going along, this would have a space complexity of also O, big O of max of m and n, where m is the length of list 1 and n is the length of list 2. Okay, sounds great. Let's look at the solution. Let's look at my submission on Leetcode and see you guys. Hey guys, welcome back. So here I have my Leetcode solution here. So basically, this is the function that was given to us, add 2 numbers, which takes in 2 lists, the head of the 2 lists, head pointers of the 2 lists. And as I described in the algorithm, I have a carry of 0. This represents the carry. This represents a dummy node, which points to the head of the list. This initially also points to the head of the dummy list, but it's going to, as we're appending the sum to our given list, this particular pointer keeps moving forward. And I have a temporary variable of total sum 0 here. This is technically not necessary. You can totally just use the carry variable as the sum and adjust it in a way, but I just had it for clarity here. So as I described above, while the first list or second list or third list, or first list or second list or carry is still present in our given list, we still have to iterate and figure out how we're going to add it up. So as usual in our inner on lines 20 to 22, if the first list is remaining, then we add the value of the first list to the head, and then we advance a pointer. So we do the same thing for the second list, right? And we also have to account for the carry, right? So that's why I said total sum plus equals carry. And then we just have to update the carry, and also at the same time we have to make sure that we set the digit. We have to append the digit, right, to our actual list. That's why I say temp.next equals that actual sum, right? And you reset the total sum. Make sure to do that, because if you don't do that, then every iteration sum will just keep increasing, right? And I advance the next pointer of my given appending list, right, of the new list I'm creating. And in the very end, like I described above before, you want to return newList.next, basically dummy pointer variables next, because that's where the actual list starts. So that's pretty much it. Let's try to submit this. Let's first run this and see what we get. Okay, your answer 708, 5 plus 2. That looks good. Let's submit it. Okay, great. So this solution seems to work, and this is in Python. And obviously, just pick your programming language and have fun coding it in your favorite programming language. All right, guys. See you in the next episode.